Let us look at the historic time scale now, which essentially is the Holocene. We don't have much history beyond that. So the end of the Ice Age started around 20,000 years ago. You often hear this terminology, last glacial maximum, which is set to about 21,000 years. So you can see that the wobbling of the temperatures begin here. So this is the temperature anomaly with respect to the base period that we have often talked about in terms of mean temperature over 1960 to 1990 or so. Okay, there is no real logic for doing that, but nonetheless having a baseline allows you, because you often don't get full temperature record of the past, but you can estimate the warmer or colder with respect to the base period and use that as the guide. So that's what it is. We were colder by about 5 degrees or so at the end of the last glacial maximum, and we started to warm up. As we said, it's related to the orbital forcing again. We talked about the Younger Dryas, which gave us this hiccup because of the sudden release of meltwater from Lake Agassiz onto the North Atlantic. Then around 10,000 years ago, the best records say agriculture, domestication of certain wild grasses that are our main crops now emerged, and it's the climate stability over this period that's often cited as one of the main ingredients for our own modern human evolution in the last 10,000 years. Okay. The other thing you can say on top of that is that the little deviations from those, the baseline of half a degree or so, have resulted in really strong impacts on civilizations that were around at the time. So that raises a question of just how vulnerable we are to climate change, global temperature change. We're already 1 degree centigrade above the mean from the beginning of the Industrial Revolution. That's how much warming has happened. So those are the things you have to worry about. The other aspects of the evolution of agriculture as a main livelihood is that the wandering of the hunter-gatherers became much less. That's supposed to have led to increased fertility because women could stay in one place, build communities, easier to have children, families to take care of the children, etc. So population began to grow as well. This period from about 9,000 years to 6,000, 4,000 years ago or so is called Holocene climatic optimum. It's not really a robust concept, but nonetheless, that's kind of the warmest period of this era, with good monsoon, as we saw, the greening of the Saharas, which we will look again, and agriculture growing widely, maybe leading to land use change in terms of deforestation and increase in carbon starting already. Okay. The medieval warm period lasted till about 1250 or so, starting in the 10th century, and this is famous, of course, for the explorers of Vikings colonizing Greenland. This warm period allowed coastal Greenlands to be occupied, and even some agriculture was carried on. And at some point, with the onset of high volcanic activity that cooled temperatures, and then came the solar minimum. So when the solar sunspots became very few, the radiation output dropped. Sunspots go up, radiation goes up, as we will see in a minute. So that created the onset of this cooling period known as the Little Ice Age. No clear evidence that it was global. 15th to 18th century, plenty of documented evidence exists that this was very strong over Europe. Okay, and then there are little things here as well. The in the beginning of the Common Era (CE), which used to be known as before Christ, after Christ, Anno Domini, and so on and so forth, also had impacts on Roman empires, etc. Okay, so climate has always been part of the civilizations going extinct, Mayas, Incas, etc. Now the question is, what is happening now? There is plenty of literature saying now also not only climate change, but even temporary changes like El Nino cause conflicts, civil conflicts, sometimes armed conflicts. There are papers arguing that the Syrian conflict started with extended drought in Syria. There are many fights over Sudan, for example. Darfur region was attributed to climate, and so on. So attribution is not easy. We will talk about this concept later on. Modern climate change in the 20th century we will look at a little bit more carefully, but the new terminology started to be emerge, I think maybe couple of decades ago by Paul Crutzen, a Nobel laureate for chemistry, who wanted to call this the Anthropocene, so end of the Holocene and the Anthropocene. But this 10,000 years of climatic stability probably enabled humans to evolve, which is our culture today. So this is the IPCC era in some sense, with projections of future climate change coming along every 7 years after starting in 1990. Now the next one is due in 2021, as we will see. We'll look at the last projection for guidance on what the future holds according to IPCC and how those projections are done. We should obviously place this in the context of long-term climate change. We have this one goes now, we had seen up to 65 million years ago. Now this one goes back to 500 millions. Be careful because these scales are not uniform. This is several hundred million years here, this is tens of millions here, and this is a couple of millennia, 1 millennium here. Okay, so the range of temperatures with respect to 1960 to 1990 baseline is pretty massive. 15 degrees warmer in the Cambrian. Remember when the explosion of new species happened, 25 million or more, and the PETM was the strongest abrupt or short-term change that was recorded, and this warming that's happening now since Industrial Revolution is much faster than the warming that happened at the Paleocene-Eocene thermal maximum. This also is not known exactly what caused it. One of the reasons hypothesized, one of the drivers, is that there are these frozen methane clathrates or hydrates. They are bubbles that are frozen and trapped in high pressure, mostly along several coastlines. So some warming or sea level change could have perturbed them and suddenly release lots of methane, which is a very strong greenhouse gas, as we saw. So that could have caused this one. We have talked about the time scale changes from obliquity to the 100,000 year cycle here. Here we are again with the last glacial maximum coming out by 10,000 years ago, and the relative stability of the Holocene period and the recent warming with projections out to 2100. So we will do that, but you can see the changes before 8500 BCE, Common Era. The population of the time was basically colonizing the water sources along the Nile. Between 8500 and 700 BCE, when the African greening of the Africa happened, Sahara was much greener, then the populations moved further west and lasted for several hundred years, more than 1,000 years. And then as the desertification started again because of orbital forcing. Remember the winter and summer insolation changes we saw before, and the population moved back towards the Nile with some other colonies where the greenery still remained. Okay, so this is another indication that the climate changes on a historic time scale have affected people movements. In our region, over India, the Mohenjo-daro, Harappa settlements around Indus were hit by this drop in rainfall for a couple of centuries. So around 5,000 years ago to let's say 3,500 years ago, the Harappans prospered, built various settlements, cities, and so on, and then monsoon all but disappeared at around the same time that the Africa got Sahara got aridified and the civilization disappeared, of course. Okay, so the drivers brought up are also considering solar output. So he talked about how we used carbon-14 as an indicator for solar activity. So this shows the change in delta C14. So remember that C14 is produced in the atmosphere all the time, and change in it recorded in tree rings and so on corresponds to the production in the atmosphere. So if there is a drop in C14 as seen by the delta C14 per mil here, then you can see that the Wolf minimum, Sporer minimum, Maunder minimum, and so on, leading up to the modern maximum, correspond to reduced number of sunspots, so reduced output, reduced amount of energy reaching Earth, so onset of the Little Ice Age and the end of the medieval warming, which led to the colonization of the Vikings, and then the Vikings went extinct. Okay, there is evidence that the Vikings also went all the way to Canada and came back, so way before Christopher Columbus landed in the Western Hemisphere. There is also some argument, some hypothesis that around 1100 to 1200 there was elevated volcanic activity. Volcanoes tend to cool the atmosphere by putting aerosols in the stratosphere, which stays there for a long time and blocks sunlight. And this is well known because in the 1800s there were some volcanoes like Krakatoa and Tambora, which created things like a summer without a year without summer, when the cooling happened, crop failures happened, and the famous painting, the Scream by Edvard Munch, came out of the beautiful sunsets that are created by volcanic emissions in the atmosphere. Okay, so those are the modern time scale changes. This is just a brief introduction, so you have to go catch up on the reading if you want to follow any of these particular time scales. I'm just running through the time scales to give you a sense of where we came from to the 20th century and where we may be headed into the 21st century.